Hey guys, welcome back. Today we're going to learn two of the most basic derivative rules that we'll use all year. The product and the quotient rule, which kind of imply when they're used. So let's get started. Okay, before we start just writing down notes the way you all do, just write. Let me tell you what this says, okay? If you're doing the derivative of a product, two things that are being multiplied together, okay, then it ends up being the first factor times the derivative of the second factor plus the second factor times the derivative of the first. Now, what in the heck did I just say? First of all, this is using notation of with respect to x. I like this version better, but let me show you what it means. I swear it's a lot easier than it looks. If I have two things I'm multiplying together, u times v, u and v, and then I've got a du and a dv. Du stands for derivative of u, dv stands for derivative of v. So the derivative of u, we're going to call that du. The derivative of v, we'll call that dv. I call this crisscross rule, product rule, crisscross. The derivative of the product of u times v is crisscross u times dv plus v times du. Okay, you still don't know what the heck that is. Go ahead and write down this rule real fast, the product rule. Put that in your notes, and I'll show you how easy it is to apply it. And then I'm not so much going to prove it, but at least maybe justify it to you, okay? So here's my first example, all right? This would be a product rule, okay? I have two functions I'm multiplying together. So first, you don't have to show your work like this, but if you're going to use my little crisscross trick, I would call this my u and this is my v. In other words, I have my first factor and my second factor, okay? Using the product rule, I now need to find the derivative of those two things. The derivative of 6x or 3x squared is 6x. The derivative of cosine x is negative sine x. The product rule says take the first factor and multiply it by the derivative of the second. That's this. Those two, multiply those. Then take your second factor, which was this, and multiply it by the derivative of the first, which is this. That's why I call it crisscross. So the derivative will be the first factor times the derivative of the second. This times this will be a negative 3x squared times sine x. Plus, because the formula has a plus sign right there, now I'm going to multiply v du, second factor times derivative of the first. I usually put the polynomial part first, so it's 6x cosine x. And that's it. That's the answer. Okay? So when it says, when it's a product of two functions, okay, the u is your first function, the v is the second function. This is du, this is dv. And it ends up being u dv, v du. But just find the derivative of both and crisscross. It works just fine. All right, so that was just the mechanics of it. Okay, next I'm going to give you an example of maybe at least justifying that it works. I'm not going to do a formal proof. Okay, so here's an example. We clearly would not use a product rule for this, because obviously there's an easier way to do this. The easy way is to rewrite it as x to the 7th, duh, and do a simple power rule. Using the power rule, the derivative of this is just 7x to the 6th. Done. That is by far the best way to do this problem. But because I at least want to appeal to your senses and justify it a little bit, let me do that same problem using the product rule. Better get the same answer. So here are my two factors, x squared and x to the 5th. So here's my two factors. Find the derivative of each. The derivative of x squared is 2x. The derivative of x to the 5th is 5x to the 4th. And crisscross. So my derivative will be x squared times 5x to the 4th is 5x to the 6th. Because when you multiply, you add. Plus, multiplying these two, it'll be 2x to the 6th. There's Mr. Sampson. Hold on a minute. So if you combine like terms, you can see you get the same answer. See? So again, that wasn't really the intention of that problem. You would never do this problem using the product rule. That would be stupid because this was way easier. I just sort of kind of wanted to justify that it works. Okay, so now let's apply that problem to something you've already learned, equation of a tangent. Okay, what two things do you need to write the equation of a tangent? Point and slope. Well, for this one, they were very nice. They already gave us the point, so now all I need is the slope. Well, the slope, another word for slope is derivative. So I go to take the derivative of this, and it's a product of two functions, so I'm going to need the product rule. So that's what changes each day. A little bit, we learn that we do the same questions, but you just learn a little bit more how to actually do the computation. So I'm going to separate my two factors, x minus 1 and e to the x. Write down the derivative of both of them. The derivative of x minus 1 would be 1. The derivative of e to the x is e to the x. And crisscross, the derivative will be, let me rewrite that, I don't have enough space. Okay, the derivative would be, okay, e to the x times x minus 1 plus 1 times e to the x. Okay, so that's my derivative, but now I need to evaluate that derivative at this point right here. You can plug in the 1 right now, or you could factor, clean it up, and then plug in the 1. It doesn't really matter since you're plugging in the number anyway. So now I'm going to find the derivative at 1. So that's e to the 1 times 1 minus 1 plus e to the 1. Well, 1 minus 1, that's 0, so that guy's gone, and I just get e to the first, or e. So that's weird, but yeah, my slope is e. So put it all together. Remember, to write the equation of a tangent, you need two things. I need my point, I need my slope, and put it in point-slope form. Y minus y1 equals m times x minus x1. It looks weird, but that's it. That's the answer. You don't need that 0 there. You could just write y equals e times x minus 1. But yep, that's the answer. Get used to the e's, get used to pi, get used to natural log. They love all that stuff on the AP exam. Okay, so that's the product rule. Multiplying when you have two functions, two different things that have x's in them. Okay, next we're going to learn the quotient rule. Go figure. Okay, the quotient rule, this one looks really tricky, but it's easy. Plus there's a little goofy song / jig that goes with it that helps you remember it. But here's what it says. And this time I'm going to do the easy problem first to justify it and then apply it to more difficult stuff. This says if you're dividing two functions, u and v, okay, the derivative will be the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. Now, that one sounds ridiculous to remember, unless I teach you my song, which, rather embarrassed, but here you go. Whenever it's the bottom, I'm going to call it low. The top, I'm going to call high. So the derivative of the bottom would be d low, and the derivative of the top would be d high. All right, work with me here. Watch. The derivative is low, d high, high, d low. Draw the line and square below. Now you got to say it with an Irish jig. I don't know why. Ready? Low-de high, high-de low, draw the line and square below. I know, I'm very embarrassed to be talking to myself right now. Yeah, it's pitiful. But low-de high, high-de low, draw the line and square below, like Lucky Charms. All right, I got to pause. I need a break. Okay, so when I say low, you're going to tell me this guy. When I say high, you're going to tell me this guy. If I say D high, it's the derivative of the top, and D low is the derivative of the bottom. So the derivative of this would be low, D high, derivative of the top. The derivative of this would be 5x to the 4th. Minus high, D low, derivative of the bottom is 2x. Draw the line, square below. Then you just have to simplify that. So it was low, D high, minus high, D low. Draw the line and square below. As I simplify it, I get 5x to the 6th minus 2x to the 6th. On the bottom, x squared times another x squared would be x to the 4th. So going further, this is 3x to the 6th over x to the 4th, which would simplify to a 3x squared. Notice if I did this original problem the way it's really meant to be done, if I just simplified the problem to begin with, this is really an x cubed, and then the derivative in one easy step is 3x squared. Okay, so the quotient rule. Here we go. Let's do it to a real problem that actually requires the quotient rule. Okay, so remember, the quotient rule says low, D high, derivative of the top, minus high, D low, derivative of the bottom. Draw the line and square below. Okay? Low D high, high D low. Draw the line and square below. Say it over and over. Low D high D low. Draw the line and square below. All right, here we go. The derivative will be low. D high is the derivative of that. The derivative of that is 1. Don't need to write that. Minus high. You need it in parentheses. D low, the derivative of the bottom, 2e to the x. Draw the line and square below. Now that is the quotient rule, but this has a good bit of cleaning it up to do. Okay, so in the numerator, you have two choices. If you put this 2e to the x here, then you could distribute a negative 2e to the x, and in the end, factor. But what you're going to learn with the quotient rule is there's a quicker way to factor. And that is, notice that we have a 2e to the x here, a 2e to the x here, and a 2e to the x here. Okay, so what I'm going to do is I'm going to factor the 2e to the x out of the numerator without prettying it up first. So I'm going to take a 2e to the x out of this and this. Visualize if I had, say, let me think, 3x minus 6. If I take a 3 out of both, I'm left with x minus 2. That's what I'm going to do. It just doesn't look like that. Okay? So I'm going to take out the 2e to the x and put it in front of parentheses. Well, just like I did here, 3 times what gives me the 3x? 2e to the x times 1 will give me back that 2e to the x. Now, what do I need to multiply 2e to the x by to get all of this? Well, I took away the 2e to the x, but I still have a negative and an x minus 1. That might be difficult to see how that works at first, but you'll get used to it. On the bottom, I have a 2e to the x squared. So now I can cancel this 2e to the x and one of these 2e to the x's. And in the numerator, I have 1 minus x plus 1 over 2e to the x. Combine like terms, and that's 2 minus x over e to the x. Okay? Now, if you didn't like this way of factoring that I started over here, then you could have put this 2e to the x here near the negative and distributed and then factored. You would have gotten the same answer. Okay, let's do one more problem using the quotient rule. And that's a big hint. Okay, when we're finished with this problem, I need you to be able to answer the question from here on out. What is the derivative of tangent? Okay, so that's what we're supposed to be able to figure out right now. And we're going to do that using the quotient rule. Well, that's a big hint. Okay, using the quotient rule, figure out the derivative of tangent. That means I need to first rewrite tangent as a quotient. What is the definition of tangent? Hopefully you said sine over cosine. All right, well, guess what? Now it's a quotient. So now let's do the derivative. Okay, so do low-d high, high-d low, draw the line and square below. I challenge you to hit pause and do this on your own right now because it's pretty cool. I bet you can figure it out all by yourself. As long as you know that that tangent is the same as sine over cosine, you can figure out this derivative all by yourself, just like Leibniz and Newton did. You're that smart. I know you can do it. Hit pause and see if you can do it. Okay, using my quotient rule, low is cosine. D high, derivative of sine, is another cosine. Minus high, sine x. D low, derivative of cosine, is negative sine. Draw the line and square below. Cosine x squared or cosine squared x, however you want to write it. Okay, well, hopefully you can see that cosine times cosine is cosine squared. And then a negative times a negative is a positive sine squared. And cosine of x quantity squared is the same as cosine squared. Okay, now you got any bells and whistles going off? Ignore the bottom for a minute. Look just at the top. What's the one Pythagorean identity that anybody ever remembers? Sine squared plus cosine squared is the same as 1. So all this numerator turns into a big fat 1, and the denominator is still cosine squared. And then by definition, what is 1 over cosine the same as? 1 over cosine is the same as secant. So 1 over cosine squared is the same as secant squared. Dun, dun, dun. So the derivative of tangent. The derivative of tangent is secant squared. Okay, add that to your list of things to memorize. Now, if you're curious, if you were wondering, and I'm sure that you were, you can derive the other 3 trig functions using the quotient rule the same way. So here's your homework. It looks like more than it is. I tried to pick and choose. I highly, highly, highly recommend you memorize, make flashcards of all of your derivative rules so far because it will get more difficult. So what do you need to know so far? We have a power rule. We have the derivative of sine, cosine, and tangent. We have the derivative of e to the x is e to the x. What else? We have a product rule and we have a quotient rule. Okay, those are all the derivatives you need to know at this point in time. Study them. Make flashcards. Start keeping a list of your flashcards or start keeping a bunch of flashcards so that you can keep adding to them. Hope you're doing okay. Good luck. Bye.